Last chance, any questions? So just to review what we were talking last time, we hit this object, this equals, and this is an equals method being written for the type class. No, course, right? Or friend. So course was the example from the lab that we did last week. But if we're going by the lecture content, this would be within the friend class. And the first thing we checked, you can't see anything.
No.
Why?
I think we need a good old power cycle here.
I hope not.
I just mean for the, oh, there we go.
Well, no, that's the...
Oh, at least it's showing some of that.
Well, now it's on, so now you can turn it off and turn it back on again and see if it works.
Why is this...
I find the more you cursor at your computer, the better it works.
Is that right? It looks like it's doing something now. There we go. All right, strange. Now it's working. So this would be for the friend or the course object. And all we're doing to check for equality, all we want to do is define when the three fields are the same, the three strings. First thing we check though is, okay, before anything, is it literally the same object? Do we have an alias? Is this an alias for the object I want to check? Is it literally the same thing? If it is, they're equal, no need to check further. Next I check if it's null. If other references nothing, or O references nothing, well, we're not equal. Something that exists doesn't equal something that doesn't exist. And if I get down here, I can conclude that O must actually exist, because if it didn't exist, we would have returned. So the thing that O references exists. O always existed, but the thing O references, I know it exists. So I check its class and to see if it's the same as this class, meaning, are they the same type? If they are the same type, now we're talking. Now we can really start to check, are they equal? If they're not, well, they're not equal. A cup and a human aren't equal. A course and a friend aren't equal, right? We're just going to say that. I guess we could define it where they could be, but we're not going to for our needs. So if I get to this line here, I know that that O must be referencing something of type course. So I cast it. I say, okay, I'm going to make another reference variable called other and have it reference the same thing O is referencing, but I'm going to be able, as far as O is concerned, because remember, O is the reference variable. As far as O is concerned, O is referencing something that's an object. And although a friend is an object, right, I don't know if the actual object that O references is in fact a friend. Remember, it could have been a cup. Now, at this stage, I do know it is, because I did this check. So I'm saying, look, I know Java, I know you're worried that other, or O, might be referencing something that's not a friend, but trust me. Have it so the other reference variable can reference, like the friend other reference variable can reference that. Because remember, the type of the reference variable and the type of the object don't necessarily need to match. It needs to be type safe, like an object is like a friend is an object, right? But any random object might not be a friend. Clear? If it's not fully clear yet, don't worry too much, but I want you to have the general idea. Yeah?
Why is friend in brackets?
This is the syntax for casting. This is saying, oh, you're a reference variable to an object? Shut up, it's a friend, it's fine. That's what that means. It's casting. If I go back here and I don't do that, it's saying, well, hold on. Other reference is an object. And an object could be referencing anything. So I can't have a course reference variable reference object. And then I'm saying, trust me, you can do it. Why? Because we confirmed it here. Okay? And now, because other is a reference variable to a course, through other, I can access the various like program code, course code, and whatnot. You may have noticed, by the way, you may not have noticed, but you may have noticed, well, hold on. Other, okay, this is a reference to like me, right? So of course I can access my private fields. How come I can access the other object's private fields. They're private. I'm not supposed to be able to access things from another instance of a class. You can. If it's private, if they're of the same type, they're accessible, by the way. So this is A-OK. If you were really worried, you could say other get program code. You could do it that way if you really wanted to, you know, but this is fine. This is safe. Even though it's private, even though other is some other instance, I can access the other instance's private stuff because I am the same class. So it's okay. All right? And then finally, we talked about this objects.equals. Now, I could say this dot program code dot equals. So program code is a string, and when I say, hey, some string dot equals, I'm asking the string, I'm using the strings equality. Program code dot equals other dot program code. And this dot course code and so on and so on and so on. Dot equals, right? I could write it like this, but this, writing it like this, we're asking each field, hey field, are you equal to this other field? Field, are you I could do it like that, but there's actually a bit of a potential bug here. Doing it this way eliminates the potential bug. Imagine for a second that if here I created a course where the first field, program code, was null. And then I ask, hey, A, are you equal to something? We go into here, and it's going to say, okay, A dot program code. So if I said, if I had this, program code would be null. And I can't ask null, are you equal to something? You can't ask null to do anything. I would get a null pointer exception and my program would crash. So to protect us from this, we have this wrapper static method, a wrapper function. And it's within the objects class. Remember, the object with the S at the end is full of static methods. Okay? Dot equals. And this one takes 2 and returns a Boolean. We can go investigate it by click equals. And now we are in the objects class. And I'm looking at the public static Boolean equals. It takes 2 objects. Notice it doesn't take 2 strings. It doesn't take 2 courses. No, it takes 2 general arbitrary objects. And we've got this fancy Boolean expression here. Mind you, this is a short-circuited one, and this is also a short-circuited one. Let's look at this side. If A equals B, remember, equals, what is equals test on objects? Sameness. Are they literally the same thing? If they are, return true, we're done. True or who cares, it's true. Return true, we're done. If it's false, meaning they're not literally copying the same thing, okay, we ignore this part. Now, all that really matters is, well, what's going on over here? The first question we ask is, hey, is A not null? Okay? A is the first thing here. That would have been like the equivalent of like this null, right? Here it is. I ask you if you're not null. If it is null, if A is not null, this is false, false, and who cares, it's false, this whole thing, it's false, not equal. If A doesn't exist, it's not equal. Okay, cool. If it is not null, then we do what I was trying to do, A dot equals B. That would have been like program code dot equals other program code. So this is just a wrapper function. And when I say wrapper function, it's a function that calls the function I really want to call with some other stuff wrapped around it, just to be safe. That's all that is. I've said it so many times, but I'm going to say it again. I am not expecting you to listen to everything I said and be like, got it, and then you're good to go. No, that's ridiculous. And I couldn't possibly show you all of the possible nuances in code, right? So when you get the assignment and you're like, he never showed me that, correct. Figure it out. You can do it. That's where we are. not only do I expect you to be able to just, kind of figure it out, like, I know you can do it. If you've made it to here, you can do that. I'm not worried, okay? Any questions? All right. Lastly, important note, this is just this right here, if it was unclear, you could read this note. It explains what I just said about the objects.equals. And then finally, there's hash code. When properly writing equals methods, you should always write another super special method called hash code. We're not going to go into the full details of what this means. It's outside the scope of this course. But long story short, we should probably write this method. A hash code is basically, how can I turn this object, if for whatever reason, you wanted to turn an object into some unique number. That's what a hash code is, right? If I've got some course object and you say, turn that into a number, but I want them all to be unique. If I had two different courses that were not equal, they should have different hash codes. But if they are equal, they should have the same hash code. That's the idea. Now, naturally, you're wondering, why would I want to do that? Don't worry about it right now. There's a lot of cool reasons why I want to do it, but don't worry about it right now. Briefly, it's a function to convert the object into some special integer hash value. Any two objects that are equal must have the same hash value, but ideally, any hash value, the hash value should aim to have different hashes if they're unequal. Any unequal object should have different hash values, but unfortunately, there's something called a hash collision. Cases where unequal things have the same hashes, it's inevitable. You're stuck with it. It's the reality of our universe. Below is an example of a hash code for the friend class. It effectively returns the sum of the hash codes of all the different parts. For a lot of simple objects, this is what you would write. You would write some variation of this for our objects. This means, okay, get the hash of this plus this plus this. This would be like the same as writing objects.hash this plus object.hash of this. It's just, it takes like a variable length parameter list, where it just sum up the hash of the individual things. Why? Because that's the way it is in Java. Once we start writing more complex objects, our hash codes will get a little bit more complex. But again, this is not something that's super critical for you to fully understand. But it's something that you're going to be kind of having to deal with a little bit. And then finally, if we wrote all this, this is how I can go create an instance of my object. This is the friend object. We were doing it with courses. We already did it with courses several times, like we saw here, right? Create a reference variable called aFriend to something of type friend. And then whenever we go to create a new instance of an object, we use this new keyword, name of the class, friend, followed by the arguments for the constructor. Because remember, this goes and calls the constructor automatically whenever we go and make an instance. And after all this is done, aFriend will reference an object that is the friend with the first name Bob, last name Smith, and email address is bsmith@gmail.com. Cool? Cool. There is a bit going on here, like I said, though. I'm declaring and assigning the variable at the same time, but yeah. Okay, be mindful, though. Be very careful. We've talked about this before, but it's important to take our time to think about these things. What is actually stored in the variable aFriend? Is it a friend? No. The object is not stored in the variable. A reference to the object is. So really I have the variable aFriend that is represented by this like box here, and the contents of that is like the memory address of like where is it in RAM. In Java, we don't think about the memory addresses. We just immediately dereference and go straight to like where the object is. But aFriend is not this, okay? aFriend is a reference to this. It's important to remember this. At this stage, people go like, so it's different than Python? No, this is the exact same way it worked in Python, okay? The only difference is primitive types. Remember with primitive types, if I had like some integer 5, well, the value 5 would be stored in the box if it's an integer. But remember, the contents of a friend is not the friend itself, it's a reference to the friend. It's important to remember this because often, myself included, but when you go and read and watch videos or whatever, learning more about this, people will often, not use the most correct language. They'll be like, okay, a friend, it's a variable storing a friend. They'll say that. They don't really mean it. They mean, okay, really it's the reference to it. And that nuance is important for how it works and understanding how and why things work the way they do, but it's not uncommon to abuse your language a little bit when describing these things. Okay? All right, if the following 2 lines of code were run, 2 instances of a friend would exist. Okay, friend A friend, Bob Smith, and B Smith, and B friend. Another one, Jane Doe. A friend would have a first name Bob. This is actually wrong. A friend would be a reference to an object that has a first name Bob. Right? Look, I did it already. B friend has a first name Jane. Well, not really. The thing B friend references has the first name Jane, right? But this is what I mean. This is the type of, this is the abusive language that I mean. We all have to know, what do I really mean here? Okay? They both have a first name, but the actual values associated with differ. Below is an example of 2 friend objects being created and being used. Anyways, there we go. So take a moment, look at this. What is being output by the above code? Well, first I'd get, okay, line 1 and 2, those creates the objects. Then I say, a friend, get your first name. Well, that should get me back Bob. And then when I print out a friend, I should see friend Bob Smith, Bob Smith. Print out Bob, or friend B, I should see friend Jane Doe, jdoe@gmail.com. And then finally, I ask, is a friend dot equals to b friend? And that will tell me, well, does a friend equal b friend? Is this null safe, though? What if a friend references null? It's possible. This would crash. So if I wanted to be super nerdy about this, I could be like objects dot equals a friend, b friend. But whatever, it's fine for here. We all just look at this and go that's not null safe, but let's just make sure it's null safe. Questions, thoughts, concerns, comments, observations, points? Yeah.
Is there a scenario where you wouldn't want your equals method to be null safe?
Not really. When you're lazy, like this, that's when I didn't bother with it, but usually you would. This would be a case of look, I'm doing this for demonstration purposes, so what's the spirit of this code? Well, I know it's null safe. But really, you should hedge and write the most correct code possible. So really, I should maybe say objects.equals, but it's okay. All right, as noted above, be careful about what is actually stored in these variables. The objects themselves are not stored there. They're the references to the objects. So in the below code, bFriend equals a friend copies the contents of a friend. This is always where students get hung up. Is they go so objects work different than primitive types. Not really. The contents of a friend gets copied. And what's the contents of a friend? It's the reference to the thing that bFriend references. So the contents get copied, right? Like this. The contents of a friend, which is the address of Bob. So imagine this has some memory address in it. Memory address 17. So memory address 17 would be there, and it references this one, okay? That's what's going on. But the contents of a friend variable is a reference to a friend. The reference stored in a friend gets copied. The friend is not copied. The result is an alias, okay? This is the same as Python. It's just review. This does also mean, though, that, judging from this image, nothing references the friend that bFriend references. So this is where Java would go oh, okay, so this object can get deleted. Okay? That's why it's so angry. Right? It can get deleted because, well, nothing references it anymore, as far as I can tell from this image. Yeah, and like I've been warning, one may feel that the assignment work, this assignment works differently between primitive types compared to objects, but this is wrong because we just have to remember what's actually stored in the variable. Is it an integer storing the number 17? Copy the contents of that variable, the number 17. Or is it a reference? Copy the contents, the reference. Okay? Give me a thumbs up if you're happy. So if you're not, if I don't see a thumb, why are you unhappy? You're very happy. Nice. All right. Now, unit tests. Like we talked, this is just from Python, like last semester. If you write code, you test your code. And I don't just mean like, okay, run it, make sure it works. Yeah, do that. But when I say test your code, I mean unit tests. Not only is it your job to write the function, the classes, the methods, it's your job to show me that it's correct. So you don't just write it, and then you write tests to show me that what you wrote was correct. That's your job as a programmer. And I don't just mean like you to me, I mean like if you're writing code, that's your job. Writing untested code, you're not done. You write your code, you write your tests. They go together. Okay? All right, so we're going to be writing unit tests for our friend class. And there are a bunch of ways we can do it. Raise your hand if you started assignment 1. Okay, and if you went through assignment 1, you would have went through the unit tests for the various classes, the 2 classes. I gave you the tests. All right? Meaning, if you wrote your code correctly, your test should pass. Okay? And most of the time, students come back to me being like, your tests are wrong because they failed. Okay, my tests are wrong, sure. Okay, so be mindful of, what's going on there. That's not to say, maybe some peculiar case I do have a mistake, but it's been a few years and, every time it's a bit of a laugh. So I gave you the test. So assignment 1 is an example of, okay, I'm giving you the test. Part of the assignment is you look at the tests and you understand the tests, okay? It's not like, oh, I gave them to you, they pass, yay. Look at them, understand them. If they don't make sense to you immediately, that's kind of the point. It's the exercise of looking at them to make them make sense to you, make you understand. The only way you learn this stuff is exposure to it. So when you write code, each unit or like component should be tested. This is called unit testing. And another word we use would be like coverage. We want our test to have good coverage, meaning like how much of our code is covered by these tests. Okay? When doing so, individual test methods are written to test the units and components. And we want these tests to be as independent from one another as possible and test independent functional units. You don't want a test that tests, you don't want a single test that tests like 4 things, because if the test fails, you go, crap, one of 4 things went wrong. Wouldn't it be better to have 4 tests with one of them fail? Now you know exactly what went wrong, right? But writing tests is a bit of an art. There's a science to it, don't get me wrong, but writing good tests, it's a bit of an art, right? And you develop this skill with practice. No one expects you to be experts at writing unit tests from the get-go. These tests are run automatically. By writing tests like this, it really adds a lot of intentionality to your code. When you're writing the tests, if you write the tests, I know you've thought about your code and your tests. Okay? That's a good thing. It obviously helps with testing and debugging, right? And does that say it if there are ever breaking changes? Ah, yes. So if someone can fix this, there's a typo. It says it. That should say if. Anyone want to make a pull request to fix that? You don't want? Somebody can.
I just made one.
You did? Nice. Well done. All right. So if there are breaking changes. So here's another thing of unit tests. You write your code. You write your tests. Now code, in general, if you work at a company, code is never like done. It's always evolving and changing, right? So maybe an update comes through. And then suddenly some of those automated tests that you already wrote break. Why? Did one of your new changes break something, right? So that's another value of the tests. And like I said, writing tests is a bit of an art, and you get good at it with practice. We are going to be using something called JUnit. It is like the quintessential testing framework for Java. In Python, we used PyTest. No, we used unit test. PyTest is another one, another popular one. In Java, we use JUnit. JUnit, though, is not like, it doesn't come with Java. It's like an external dependency, but it's so wildly common. It's a great tool. It's simple to use for automated testing, and with IntelliJ, it's actually pretty simple to set up JUnit tests. Okay? So here's how you do it. If I'm here, right, all of our projects, so you don't have to do it this way, but you have to do it this way. Okay? Within here, within a project, you often have several files, or folders, right? Out, that's where some like compiled crap goes. Sometimes if you have like external resources, like a text file your program needs to read, that might be in another folder called like resources or something. Your code is in the SRC folder for your source code, and your tests are always in a folder called test. Now you'll look here and be like, well, there is no folder called test. Okay? That's easy. You right-click on your project, new, directory. Folder, directory, same difference. Click it. And what do I want to call it? Test. And look at that. It actually already made it green. That's wonderful. That must be a new feature. Because it used to be the case where test was just a regular old folder. And you would need to go, right-click it, and give it a special designation. You right-click it, you scroll down, mark directory as test source root. Looks like we don't need to do that anymore. It's already there. Let's just mark directory as, yeah. Oh, I guess maybe I did. So we'll still do that because it added a couple of more symbols to the little image, and maybe that's important. So there we go. I created a test folder, and then I told IntelliJ, this is where the tests are. Cool? Cool. You're not expected to memorize what I'm showing you, but I want you to memorize the fact that I've got a website that shows you how to do it, so you can follow along when you need to. Okay, great. Now, we're going to create a class for each class we want to test. So within this code, I only have one class I want to test. If I look at source, I've got course. Usually, like your top level class where your main is, you don't write tests for that. That's just where you're like, you just call everything else that has already been tested. But this course class, I want to write tests for this course class. Okay? So I go here, I right-click, new. Something in here should say something about Java, right? Where's the file, I guess? Surprised it's not letting me like new Java. All right, whatever. And there's a convention. We call it name of the class followed by the word test. I believe, I could be wrong, I believe this is just a convention. It doesn't need to be called this, but again, it needs to be called this. In Python, we had a different convention. It was test whatever file you wanted to test, right? That's what we would do. But in Python, the first name, like the first part of your test class or your test file had to be called test. I don't think it has to be called like this, but we're going to call it that for a convention to follow. So here I want course test.java. Why is it like this, though? This doesn't seem right. I'm wondering if they've changed something in IntelliJ that's making it. Huh.
You know what's not going to change on you?
What?
Notepad++.
That's true. All right, let's see. New. Okay, for some reason, this is interesting. Test resources root. I misread. It was already designated as test. When I did it the second time, it was test resources root, and then I got all giddy because it had extra little symbols, and I was like, oh, that's fun. Well, it turns out I didn't want that. I want it to be test, not test resources, just test. And now it's happier when I go right-click, new Java class, course test. There we go. There we go. Now, unfortunately, two unfortunate things I'm about to show you. The first unfortunate thing is, well, no big deal. Like I said, JUnit doesn't come out of the box with Java. You have Java installed on your computer, but you might not have JUnit installed. But don't worry. It's really easy to get because IntelliJ will kind of figure this out for you. And here's the trick. All you have to do is go to use one of the important keywords from JUnit. And if you use one of the important keywords, IntelliJ will recognize it and be like, hey, you're trying to use something like JUnit, but you don't have it. Do you want me to get it? And so that's what we're going to do. Okay? So one of the important keywords is @test. And is it uppercase T? It is uppercase T. Okay. @test. But it's going to be like, hey, I don't have that. And that's what I mean. I hover over it, and it's saying cannot resolve symbol test. And you will see something very unfortunate. It's /helpful, but /unfortunate and unhelpful. You will see it's like, oh, hey, you want JUnit? Yes, but I don't know why. This is it's been years of this. I don't know why, but it wants to add JUnit 4. That's an old version that's going to give us problems. I don't know why that's the one it wants to show us, right? So what I would do is go over, is first and foremost, listen to me very carefully. Do not click this. Do not. If you click it accidentally, you're screwed, okay? It's going to mess everything up. And if you do that, and you come to my office hours and you go like, oh man, I messed up and I clicked add JUnit 4, I'm going to say, that sucks, start over. It's honestly easier to just create a new project. Obviously, you can keep what you wrote and just copy and paste it into the new project, but you're going to have a better time if you just start a new project and copy your stuff over, because otherwise it's a nightmare. So do not click that. Do not accidentally click it. You're going to have a bad time. Instead, you do more actions. And they'll be like, oh, you probably want this one, obviously. So you click JUnit 5, whatever. I think in mine, it's even like 5.7, so it's an even newer one. But as long as it's 5, you're going to be happy.
I think it's just sorted alphabetically.
That could be it. It could be.
It's terrible.
But they should, And then it's going to be like, oh, org.j, yeah, that's what I want. Okay, yep, okay, cool. And then it's going to do its magic, and bingo, bango, we're all set. We've got it. Now it's mad because it's like, well, okay, import the class. And we haven't done anything with it yet, but there we go. Long story short, you don't have it there. IntelliJ will try to get it for you, but it will suggest the wrong one. And you have to be like, more options, the right one. Okay? And don't cause yourself any pain and click 4 by accident. So they say, do not select 4. That will cause issues with the tests. Okay, great. You can also do Alt-Enter. A lot of things like Alt-Enter. Now here that won't do anything. But if I hovered over it and pressed Alt-Enter, just when I clicked more actions, that little window would have been the same thing. Cool. Questions so far? This is just setup. We haven't written any tests yet. All right. Great. Now we're all set. So let's start writing some tests. These tags are important for Java. Okay? So here I say @test. This tells Java or JUnit like, okay, this is a test method. Void, it's common to not include visibility modifiers here. We just don't for the sake of the unit tests. Return type is void. I want to write a test for each piece of functionality for this class. There's not a lot of functionality in this class. It's a simple friend class, right? All we have is a couple of accessors, equals, and 2 string. So let's test those things. So test get first name, general case, returns first name. Remember how we had a convention last semester where it was like what we're testing, special case, what we expect, we're going to follow the same thing. Except because we use camel case, it's even clearer. Remember last semester, because of snake case in Python, it would be like these long, like get underscore first underscore name underscore general underscore case underscore and so on. Well, the camel case makes this a little nicer. What we're testing, what's the condition, what we expect. Okay, so what does this test need to do? Create an instance of a friend. Whatever values it has, it doesn't matter. All I care about is when I say get first name, I better get that one back. So assert equals, that's a built-in JUnit thing. We had something very similar with Python's unit test. I think it was like self.assert equals, something like that, right? So assert equals QWERTY and friend.getFirstName. That better be true. If not, the test fails. Cool? Cool. The at test is important. It has a descriptive name of the form unit under test underscore case underscore expected result. So get first name is the unit under test. General case, nothing special is happening here. There's really no special case here. And then what do I expect? Well, I better get the first name back. Yeah, and we're using a special built-in JUnit method called assert equals. Cool. Any questions about this? This follows a remarkably similar pattern to what you would have been used to from Python. Okay? So here's another one. Equals. Equal friend objects are equal. Maybe that should have been called like returns true, whatever. But there we go. In fact, I really do think it would be better to have like returns true, but it is what it is at this stage. So this one is friend A, friend B. As per how I've defined them, they better be equal, right? So assert equals A friend, B friend. Notice here, assert equals. How does it know what it means for two friend objects to be equal? Well, it goes and looks at the friends class as equal method, right? That's how, right? It would call the objects under tests equals method. Cool? So equals unequal friends are not equal. Probably should say return false, but whatever. Good enough. So the tests are named such that the case equal unequal is a little clearer. Okay? So here, this is what I showed you, like general case. There's really no special case for get first name. But for equals, well, there's cases. Are they equal? Are they not equal? Right? Right. Note, by the way, typically, this is annoying. This is a Java thing, and it's not a Java thing. This is just a nature of the beast type thing. It turns out that checking if things are equal is testing equals methods is a lot more painful than you realize for a variety of reasons, mostly outside the scope of this course. So for our purposes, that equal method is sufficient. It's fine, right? But they could be improved. If you look at the friend test class I give you to download, which is linked in here in several places, I think you can download it here if you wanted. By the way, when you download these things, if you look, I click this, right? And if keep, open. Okay, I open it in IntelliJ, but you'll notice it's not in the project, I don't think. Like, this is the test class, right? If I were to, I could open this in Notepad, whatever, and I could copy and paste this into a project. It's fine, whatever. If you're ever looking at the code I give you and you see some of these like special comment tags, you can ignore those. Those are comment tags. When I build the website, I say like, hey, and go copy the chunk of code between this tag and this tag. That's all. So those are just for the sake of the website being generated. So if I change this code, the website automatically gets changed. That's all. So don't worry too much. Okay, all right. Yeah, though in mine, in the tests I give you, I use a better system for testing equals, something called equals verifier. It's another external dependency that's not included with Java, IntelliJ, or JUnit. It would be another one where you have to be like Alt-Enter. Yes, download it for me. And here's an example of me using it. It's not important for right now, but this would be an example of something that you would see, and then it's like, well, you'll figure it out as you go. Okay? Cool. It does a lot of extra special tests for equals. Yeah. You have a question, or was it just a stretch? Cool. All right, so there we go. And let's go back here, okay? If we go look at the friends, okay. I mean, this is the text here, right? You don't even need to download it. You can just copy all this. What are all the tests here, right? Get first name, general case returns first name. Get last name, get email, equals, toString, and then here's the better, equals, verify contract, whatever. This is the fancy equals verifier thing. Cool? It's a very simple test class. And if you look at the code I give you in assignment 1, the countries test class is going to look very similar to this, just for its various methods and fields, right? There's another method that you have to write for it, like get population density, right? Which does a calculation, so there's something a little bit more there to test, but it follows the same pattern. Nothing weird here. Raise your hand if you started the assignment. You're like, well, I want to run the test. Oh, I can't because the other class isn't written, and of course all those tests are going to fail. But how do I do that, right? Have you tried that and come across that issue? Well, if you do, just comment out the tests. Just go to the whole country catalog test file and comment everything out. And if you're like, comment out every line, well, yeah, there's an easy way to do it. You could just highlight what you want to comment out, and then Control/ will comment whatever you have highlighted, by the way. And you're like, well, how do I undo that? Do that again. Control/. There you go. I know, right? Like at least 6 people's face was just like, what? Was like, yeah, you too. It's great. Pardon? It is, right? There's a lot of like cool hotkeys that you'll kind of figure out as you go. What's up? That's an IntelliJ thing, yeah. If I go to like a text editor and do that, and it's going to it'll be like /, okay. Yeah, it's an IntelliJ thing. So what I mean is, like, you didn't write the country catalog test, or you didn't write the country catalog class yet, but you wrote the country class. And you want to run the country tests. And you go to run it, but it says, I can't run because the whole country catalog isn't done yet. Well, just go comment all that crap out, and then run your country tests. And if it's good, then you're probably in good shape. Just because the test passed doesn't mean you're correct, but it's a pretty darn good pretty darn good indication that you're doing something right. Okay? Notwithstanding you changing the tests to make your code pass the tests, which sounds ridiculous, but students try to, all my tests pass. Well, you changed the tests to make it so they would pass for your broken code. I can't do that? What? It's wild. So when in doubt, if it's not working, just comment out stuff until it works. And then when you want to add it, uncomment it. Uncomment it, you know what I mean. Yeah. Yeah. Cool? Happy, sad? All right, neat. Again, nothing about what I'm showing you is something that you're expected to have memorized. It would be impossible for me to show you every nuance there is with these tests. You just do it, you figure it out, you have a question, you look it up, you implement it. I just need you to be familiar enough where you can do that, right? I give you the tests and the assignments so you can look at them and learn from them. Cool? Now, I will warn you though, there is a whole other topic on tests coming up here. This first topic was really short, and it was really short, and it's for a very simple class that we're testing. We're about to start making data structures, and data structures are very complex classes. And as a result, they're a lot more painful to test. They're also very stateful. There's a lot of reasons why they're hard to test. They're stateful. Methods are like inextricably connected. Like you can't test remove without doing adds, but if I haven't tested add, how do I test? You know, like there's a lot of reasons why testing collections, data structures, is very difficult. So a simple class that's like a data class with maybe a couple of methods, like a country class. Straightforward to test. That's nice. We like that. A lot of classes that you're going to write if you become a programmer are going to be like that. But every once in a while you have to write like a big, beefy, complex class like a data structure, which is a pain in the ass to test. So we're going to have another topic going over that. And that's why, like how many tests are there for the country class? Like a dozen or so? And then if you go to the country catalog test, there's hundreds and hundreds, pardon? 73 tests, right? And all these different cases and everything. Yeah. Okay? And that's not even that thorough. Okay? So, yeah, they become a little bit more painful. But don't worry, we're going to have like a coping mechanism. Okay? That's the best way to word it. I saw a hand. Did I see somebody's hand? No? All right. Okay, unit tests. So, data structure review. All right, well, data structures. You've already written them. Last semester, we did a bunch. We did like the widgets collection, the inventory on the exam. There was like friends list, contact list, the country catalog. We all, a bunch of examples from last semester. We're going to be doing the same thing again, but in Java. So the underlying idea isn't new, but the implementation in Java will be what's new. But of course, it's also it's a review exercise to make sure we're all on the same page, okay? So although Python code was included in the previous topic, I showed you the Python and the Java, I'm not going to do that anymore. Goodbye, Python, okay? We're only going to stick with the Java stuff. So, with a friend class complete, there needs to be a way to keep track and manage the friend objects. That was the whole point of this exercise, right? We want a collection, we want a way to keep track of a bunch of friends. So let's make the friend class. Now let's keep track of them with some other object. That's the data structure we're making here. And we're going to call it a contact list. So what field should it have? Well, I'm going to need a way to keep track of the friends in the contact list. And if we think back to how we did something like that in Python, well, we used a list. But remember, we don't have lists in Java. But we have something similar-ish, kinda, called arrays. So we'll use an array. But remember, arrays are limited. With arrays, we have fixed sizes, right? Thinking that might be a problem here, right? Like, how big should that array be? How big should the array be? Yeah. Pick any number, we got a problem. Right? Infinite, well, no, nice try. You can't do that. If you pick any finite number, you're going to have a problem. Let's make it 10. What happens if I want 11 friends?
Make it the integer limit.
Make it integer limit. Okay, problem solved, yeah. Well, more on that in a moment. So we're going to want a field to keep track of the friends. And we're also going to want a field to keep track of the number of friends in our list. Now you might say, or in our contact list, but you might say, well, isn't that just the number of things in the array? Well, yeah, but remember, arrays are different. We'll see. I'll give you a spoiler, because we're almost out of time. I'll give you a spoiler. Here's the trick that we do, is when you create a new contact list, you create an array of some arbitrary size. Let's say 10, okay? Ooh, not good. All right, that's an array of size 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. There, now it's 10, right? But it's empty. So we've got an array that's going to keep track of our friend objects, but how many things are in it? 0. So that's what those two fields are going to be. There's going to be the array of friends and the number of friends that are actually in that array. If I add 1, this becomes 1. So that's the idea. So we have an array, but it's just a bunch of like empty seats where I could add people. But of course, we have that problem of what happens when we want it. Like, well, I've got, how many people would be in this array now? 10. What happens if I want to add an 11th? Ugh. We'll talk about that on Friday. All right, I'll catch you all later.
Aren't the seats not actually empty though?
Well, they'll be
Like
null. There'll be references to nothing. Yeah.